Welcome back, guys and dolls. Now that we have our data, let's get into the WooCommerce data flow to our dashboard. On page load or filter selection, dashboard.tsx immediately calls our use dashboard data TS hook, and this is the brain of our entire operation. Use dashboard data TSX reaches out to WooCommerce service TSX to fetch the order data. The WooCommerce service calls API credential service TS to grab the store URL, client ID, and client secret that we've securely stored in Supabase. Armed with those credentials, WooCom service hits the WooCommerce database via the REST API, pulls all that juicy order data, and sends it back up the chain to use dashboard data TS. Now here's where our hook shows its intelligence. It does two critical things simultaneously. First, it ropes this fresh data to cache service TS, which stores everything in local storage for fast future loads. Second, it immediately passes the processed data to our UI components. The data flows out to three specialized components. KPI cards.tsx receives the aggregated metrics, total revenue, order counts, average order values, and displays them in those beautiful cards at the top. Charts section TSX gets the time series data and transforms it into that compelling revenue trends bar chart. Orders table.tsx receives the detailed order information and renders that comprehensive table at the bottom with order IDs, dates, coupon codes, and customer details. And that's the complete WooCommerce data flow. Next, we'll explore how Google Analytics data follows a similar but more complex path through our serverless functions. Alright, and now we're diving into the Google Analytics data flow, and this one's a bit more complex than our WooCommerce setup. This is where we had to get creative to solve the CORS problem that was blocking our direct API calls. Dashboard TXX calls or use GA4 data TS hook. This is our specialized brain for handling all Google Analytics operations. Now here's where things get interesting. Use GA4 data TS needs to talk to Google Analytics, so it reaches out to GA4 service.ts. But GA4 service TS has a problem. It can't make direct calls to Google Analytics because of CORS restrictions. Browsers simply won't allow it. So here's our clever workaround. Instead of making a direct API call, GA4 service makes an HTTP request to our Google Cloud function at functions/GA4proxy-index.js. This serverless function acts as our middleman, completely bypassing the CORS issue. The Google Cloud function takes our credentials and filter parameters, makes the actual API call to Google Analytics, pulls all that valuable click data and event information, then sends it back to GA4 service.ts. GA4 service TS receives the data and passes it back up to use GA4 data TS. Now our hook does the same smart split we saw with WooCommerce. The data flows out to two specialized components. KPI cards receives the total clicks data and displays it in that fourth analytics card alongside our WooCommerce metrics. Chart section.txx gets the clicks over time data and transforms it into those compelling trend visualizations showing how our QR code campaigns are performing. Each component renders its Google Analytics data perfectly into that first line chart in the dashboard. And that's our complete Google Analytics data flow. Now, before I end this series, let me quickly go over that Google Cloud deployment of our serverless function. Okay, this is the link in the middle. I clicked to download and install the Windows installer for the Google Cloud CLI. I'll include this URL in the description section. Let's go next. Alright, yes, that was the last block of my Google Cloud installation process. That's when I stopped to ask Gemini to give me some guidance. I basically told me to keep all of them checked and hit the finish button to move forward. And that's what I did. This is what happened next. After hitting that finish button, the installer walked me through this command prompt step by step to finish the installation and had me logged in using my Google Cloud account. It was straightforward. After that, I verified the GA4 data proxy script line by line that Gemini CLI wrote. It was like reading poetry. Once done, I dropped that long command above that Gemini gave me into that CLI at the bottom and hit enter. Boom! Our cloud deployment of our function was success. Now I had to verify that from the Google console next. On the Google Cloud Console, I had to search for cloud functions. That's how I got that first search result, Cloud Run Functions, and I click on it. Let's see what happened next. This was the next screen, and I found my project, so I clicked on it. Let's see what happened next. Yes, that's where I found our function folder GA4 data proxy. Everything looked great, but I had to dig deeper because the function wasn't working. So, let's see what happens when I click that link next. Okay, finally, I was in the right place to troubleshoot the issue. Yes, that very long link is the URL I used from our GA4 service.ts file to connect to Google Analytics. Don't worry about that big Node.js 18 warning. Our script deployment was successful regardless, but it's better to upgrade the Node.js version to the latest. And yes, to fix our issue, I had to click on that Logs tab, and let's see what happens next. Yes, finally. Yup, that's log we need to look at to troubleshoot our Google CUD issues. I have to admit, deploying that function was only the half of the story. 'Cause, honestly, I had to do a bunch of back and forth with that log, and a few more redeployment later. It was perfect. And with that, and by thanking my friend, Gemini 2.5 Pro, I conclude this series. Thanks for watching.